need to integrate your FastMCP server into an existing web application without breaking your current routes. You'll see how to mount a FastMCP server as a sub-application in Starlette, exposing MCP tools alongside your existing API endpoints, all while sharing the same domain and infrastructure. The pattern keeps your MCP server cleanly separated but fully accessible under a dedicated path. From FastMCP, import FastMCP. From Starlette, applications import Starlette. From Starlette, routing import mount. Hash create your FastMCP server. MCP equals FastMCP, my server. At MCP, tool. Def analyze data, SDR, dict. Return, result, F analyzed, data. Hash create the ASGI app. MCP app equals MCP. HTTP app, path equals /MCP. Hash create a Starlette app and mount the MCP server. App equals Starlette. Routes equals mount /MCP server. App equals MCP app. Hash add other routes as needed. Lifespan equals MCP app. Lifespan. This demonstrates the ASGI integration pattern for embedding specialized services within larger web applications. The key concept is composition through mounting, where a FastMCP server becomes a self-contained sub-application within a Starlette routing hierarchy. What makes this distinctive is the clean separation between the RPC service layer and the HTTP transport layer, with each maintaining independent concerns while sharing the same process space. The pattern works by leveraging ASGI's standardized interface for Python web applications. The FastMCP server exposes itself as an ASGI-compatible application that can be mounted at any path endpoint, while the parent Starlette application manages the overall request, routing, and lifecycle. This creates a modular architecture where the MCP protocol endpoints coexist with other web routes, sharing infrastructure like middleware and authentication while maintaining their own session management through the lifespan context. This approach solves the problem of service fragmentation by allowing RPC capabilities to live alongside traditional web endpoints in a single deployment. It's particularly valuable when you need to expose AI-callable tools alongside REST APIs, or when integrating MCP services into existing web applications. The trade-off is slightly increased complexity in routing configuration, but the benefit is unified deployment, shared resources, and simpler infrastructure management compared to running separate services. Let's break it down. From FastMCP, import FastMCP. From Starlette, applications import Starlette. From Starlette, routing import mount. These imports establish the core dependencies. FastMCP for creating AI-callable tool servers, Starlette as the ASGI framework foundation, and mount to integrate the MCP server under a specific URL path. This is the standard setup pattern when embedding FastMCP within a larger web application. Hash create your FastMCP server. MCP equals FastMCP, my server. This instantiates the FastMCP server, the central orchestrator for AI-callable tools. The string parameter, myServer, identifies this instance in logs and error reporting, enabling traceability across distributed systems. At MCP, tool. Def analyze data, SDR, dict. Return, result, F analyzed, data. The @MCP tool decorator registers this function as an AI-callable tool. FastMCP automatically generates an open API-compatible schema from the type hints and docstring, enabling AI models to discover and invoke it with proper input validation. This is the core pattern for exposing Python functions to AI agents, decorate the function, define typed parameters, and return structured data. The decorator handles serialization, validation, and error reporting.
Hash create the ASGI app. MCP app equals MCP. HTTP app path equals /MCP.
This converts the FastMCP instance into an ASGI-compatible application. The path prefix /MCP scopes all tool endpoints under this root, preventing collisions with other routes in the larger application.
App equals Starlette. Routes equals.
This initializes a Starlette application with root configuration. The routes parameter defines all URL endpoints, where each entry maps a path to its handler, here mounting the MCP server at /MCP server. This is the standard ASGI composition pattern for integrating multiple apps under shared middleware. FastMCP ASGI integration. Mounting your FastMCP server as an ASGI app enables seamless integration with Starlette, FastAPI, and other ASGI frameworks while preserving all tool functionality. The lifespan context must be properly propagated from the MCP app to the parent application or session management will silently fail. This pattern lets you embed AI-callable tools alongside traditional web routes in a single deployment.
The mounted server that disappears into the framework becomes the framework itself.